Welcome again. Welcome. It is so many days after which we are meeting here. I was busy in some other works, that is why I wouldn't be able to upload some videos for you. Sorry for that. So today's topic is very important derivation that we are going to see now. The topic, the derivation is electric field due to a dipole at a point on the equatorial plane. On the axial line, if you calculate what will be the electric field that we have discussed in the last video. So this is also very important. So listen carefully and you can write down also. So we have to consider a dipole first. First of all, we have to consider a dipole. So this is the dipole I have considered. Here, two charges plus q minus q. Of course, you know they are separated by 2a, then you call that as dipole. The distance between the two charges is 2a. And this is P 2aq, product of 2a and q. That is the dipole moment. Direction of dipole moment that you know from minus q to plus q. And in this figure, we have considered a point P here. This is the point P, or whatever the point we have considered here. At that point lies on the equatorial plane of the dipole. So at this point, what is the electric field that we are going to see? So the two charges plus q and minus q both will have electric field at this point. Due to both the charges, electric field will be there. The direction of those electric fields are, you can see in the picture, E plus q outward, E minus q inward towards the charge as it is negative charge. And the distance between the center of dipole to the point of consideration is r, that we have taken here. This is a, this distance is a, half of 2a. That is why this distance is root of r square plus a square. From Pythagoras theorem we have it is equal to root of r square plus a square. Okay, this much you understand first. And then what we have to do is, we have to write equation for magnitude of electric field. Remember, it is only for magnitude of electric field due to minus q. We are considering magnitude only first. E minus q, magnitude of this 1 by 4 pi epsilon naught q by r square plus a square. Why it is r square plus a square? You may have got doubt. The reason is the distance between this minus q and p is the same as root of r square plus a square. It's a square here equation wise. That gives r square plus a square. Right. Similarly for plus q, electric field due to this plus q, I have written it as a plus q equal to 1 by 4 pi epsilon naught q by r square plus a square. Same equation. As we have not considered the direction or the sign of the charge, we can write like this. Only the magnitude we have chosen. So from this figure, this is the resultant electric field. Two electric fields, E plus q and E minus q, they are vectors, you know. Due to that, I can use parallelogram law of vector addition and I can add them up. And if I do so, this will be the resultant E. And therefore, from the figure I can write this E is E plus Q cos theta plus E minus Q cos theta. Why it is so? The reason is, you can see another diagram here, the enlargement of this only, this. So this angle is theta. This is the direction of E plus Q. This is the direction of E minus Q. So this is also theta. If I split this vector E plus Q into two components, horizontal and vertical. Horizontal component is E plus Q cos theta and vertical component is E plus Q sin theta. Similarly, the same thing I have done for E minus Q. So you can see these two are same in magnitude and opposite in direction, E plus Q sin theta and E minus Q sin theta. So the vertical components of the two vectors cancel out here. These cancel out, so what is remaining is E plus Q cos theta and E minus Q cos theta. So their sum should be equal to E. So that is why I got this. E plus Q cos theta plus E minus Q cos theta is E into P cap minus P cap. Why it is minus P cap means the unit vector I have considered as minus P cap. That is, this is the direction of dipole moment, right? Minus charge to plus the charge. So we are considering E in the opposite direction to the direction of dipole moment. That is why minus sign here. So here in the two terms inside the brackets, cos theta and cos theta. Okay, right. Two terms you have. This is common. Cos theta is common. So I can take it out. Cos theta here. So E plus Q plus E minus Q into cos theta into minus P cap. So from equation 1 and 2, so which are equation 1 and equation 2, you can see from these two I can just substitute the values of E plus Q and E minus Q. So first E plus Q I have written here 1 by 4 pi epsilon naught Q by R square plus A square plus E minus Q, that is 1 by 4 pi epsilon naught again Q by R square plus A square, and then the remaining thing outside the bracket cos theta into P cap. That is equal to minus of 1 by 4 pi epsilon naught 2Q. Why? 2 times, right? So 2Q by R square plus A square. Same term 2 times, that is why 2 here into cos theta P cap. Again, simplifying again at minus 1 by 4 pi epsilon naught 2Q by R square plus A square. What is this cos theta? For cos theta from the diagram I can write A by root of R square plus A square. How it is? Let us see. You know this angle we have considered as theta. So this angle is also theta. So if I take cos theta in this particular triangle, what will we get? It is cos theta is opposite, this adjacent side, that is this side, A. Adjacent side divided by hypotenuse A by root of R square plus A square. From that I have got this cos theta is this much, A by R square plus A square. That one into P cap. Okay. So E equal to minus of 1 by 4 pi epsilon naught 2Q into A here, 2QA divided by R square plus A square, this term, into root of R square plus A square. That the same is R square plus A square to the power 1 by 2. Root can be written as 1 by 2 into P cap. So this much is clear, I hope. That is equal to minus of 1 by 4 pi epsilon naught 2QA or 2AQ. What is that? P, dipole moment. So in place of this, I can write this P. 1 by 4 pi epsilon naught P by R square plus A square. This is R square plus A square means it's a power 1 into R square plus A square to the power 1 by 2. So totally, if you multiply these two, I can write that as minus of 1 by 4 pi epsilon naught p by r square plus e square to the power 1 plus 1 by 2. Correct, no? Got it? Yes, 1 plus 1 by 2. This 1 plus 1 by 2. When you multiply, you can write like that into p cap. So, this e can be written as minus of 1 by 4 pi epsilon naught p by r square plus a square to the power 1 plus 1 by 2. That is 3 by 2. Very simple mathematics. Right? Addition. So that I got as 3 by 2 into p cap. Suppose, now we are applying physics. We are neglecting something by giving the reason that if r is very much greater than a, if r is very much greater than a, we can neglect a here. Correct, no? So, the next step we can write e equal to minus of 1 by 4 pi epsilon naught p by a is neglected, so what is remaining is this r square only, r square to the power 3 by 2 into p cap. Correct, no? Yes, therefore that is equal to minus 1 by 4 pi epsilon naught p by r cube. Why is cube? These twos will be cancelling each other, so remaining is r cube. So 1 by 4 pi epsilon naught p by r cube to the power, r cube into p cap. Correct, p cap is unit vector. So finally I can write E is equal to minus of 1 by 4 pi epsilon naught p by r cube. What is this p? P vector. Dipole moment. Right? Dipole moment is as a vector. So this is the equation that we are going to we derived now, right? The equation, it is for what? It is for electric field due to dipole at a point on the equatorial plane. On the equatorial plane, right? Got it? The point is P. At this point, what is the electric field? If you ask, this is the value of the electric field. What is this P? Dipole moment to AQ. What is this R? The distance between the center of dipole to the point of consideration. Correct, no? Okay, all these are constants. 4 pi epsilon naught. Right? So you got it. I hope you got it. Very important. Keep a note and write it. And then again practice 3 or 4 times. And be careful. And watch. Please keep watching. Thank you. We'll meet in the next video.